18, it says from 1984 to 1985, the mean height is 172.36 and the standard deviation is 6.34. So what we're looking for here is 68% of the score. So that's one standard deviation below and above. Now keep in mind, z-scores are standard deviations. So when you're going one below and one above, the z-scores are going to be -1 and +1. So all I have to do is take my mean, which is the middle of the normal curve, and I've got to subtract one standard deviation, which is 6.34, and add one standard deviation. And that's how I come up with these numbers, 166.02 and 178.7. This clearly shows the mean, 172.36, minus a standard deviation, and then plus a standard deviation. Now, to get 95% of the scores, you've got to go 2 standard deviations. So that means z-scores are -2 and 2. And if I add 2 6.34s and subtract 2 6.34s, I get 159.68. That work is shown up above here, by the way, and 185.04. And lastly, 99.7% of the scores, they are contained within 3 standard deviations, which means z-scores of -3 and 3. And here's my work for, here was my work, for adding and subtracting 2. Here is my work for adding and subtracting 3 standard deviations or z-scores. So that's 153.34 and 191.38. In the United States, the ages of 13 to 55 plus smartphone users pretty much follow a normal distribution. Ding, 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 normal curve, second bars, with approximate mean and standard deviation of 36.9 years and 13.9 years. So the mean is 36.9. The standard deviation is 13.9. Using this information, answer the following questions and round your answers to 1 decimal place. Calculate the interquartile range. So the interquartile range is the range between the 25th and 75th percentile. So first I do the 25th percentile. And again, it's second bars inverse norm, the percentile, in this case 0.25, the mean, which is 36.9, and the standard deviation, which is 13.9. For quartile 1, I come out with 27.52. I do the same exact formula, but this time I plug in a 0.75 instead of a 0.25, and I get 46.28. And then the interquartile range is the difference between them. So I subtract 46.28 minus 27.52, and I get 18.76. Then it says 40% of the smartphone users from 13 to 55 are at least what age? So if you're at the 40th percentile, then that means if they're older than that, then they're at least that age. So I do second bars inverse norm, and I want to be 40 percentile, so that's 0.40%. 36.9 is the mean, 13.9 is the standard deviation, and it says 33.38. Okay. The mean and the standard deviation of a population are 440 respectively. Sample size is 25. What's the standard error? Well, the standard error would be the standard deviation divided by the square root of 25. Standard deviation is 40. Divide that by the square root of 25, which is 5. 40 divided by 5, all of my work is right here, is 8. Okay. Next up, when I did this question the first time, I started wrong because I didn't read it right, because I was listening to Leonard Skinner stuff. A group of 625 students has a mean age of 15.8 and a standard deviation of 0.6. The ages are normally distributed. What's the probability that a randomly selected student is older than 16.5? So this is not central limit theorem stuff. So here's my normal distribution stuff. X tilde normal distribution, 15.8 mean, and 0.6 is my standard deviation. And I go into the calculator, I do second bars normal CDF, and it wants to be older than 16.5. So the youngest is 16.5, and then 10 to the 99th, the mean of 15.8, and 0.6 is my standard deviation. And when that crunches out, I come out with 0.12167. And would you look at that? Here's my first mistake. Ding, 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 ding. It's on question number 4 here. I did all the work right. I just didn't circle the correct one. I should have circled 0.121. And you know what? Maybe I didn't, because if you want to be real technical, because it was 1216, maybe it should have been 0.122, but if it was that close on a test and I ever did that to you, you better make sure I give you credit for 0.1222. My choices would be like 0.864, 0.879, 0.122, 0.119. It would be far enough away that there would be no doubt about it. Okay? So I think 0.121 is the best way to go here, even though when you round this off, you do get 0.122. Suppose teenagers that attend a public high school get an average of 5.7 hours sleep each night with a standard deviation of 1.7 hours. What's the probability randomly selected group of 35 high school students gets more than 6 hours sleep each night? Okay. Normal, the mean is 5.7 and 1.7 is your standard deviation. So second bar is normal CDF. You want at least 6 hours sleep a night. They get more than, so 6 is the lower end, 10 to the 99th is the highest end. 5.7 is the mean, 1.7 is the standard deviation. I come up with 0.430. Okay. I'll pick up on number 22 with the next video.